Hello everyone and welcome to our tutorial on predicting the products of double replacement. So what I'm going to do is guide us through an example of practice from your worksheet and show you how to do it based on the information that you learned in the lecture. So first we want to talk about how we know that these are double replacement reactions. So when we look over here, it says to identify based on the reactants. Well, it's not two elements because silver nitrate and potassium phosphate are compounds. It's not a single compound, there's two of them. And here I see I have a compound and a compound. So I have double replacement. So when I look at these and I look at the precipitation reactions, I care about solubility rules, and we're going to see that chart again in just a moment. If it appears to be a neutralization reaction, I'm going to have kind of like a different kind of compounds. This one will typically involve an acid and a base, which means I have hydrogen in one of them and an ionic compound for the other. Those produce water and an ionic compound. Here, I'm looking at metals in the compound switching places. So I have two ionic compounds. So I'm just going to kind of note that. These are both ionic. So that's part of what helps us know that it's going to be a solubility rule type situation. So the first thing I want to do is make the switch. And oftentimes this is actually easier with the names before we write the formulas. So the silver, I'm going to box. Remember, we box our metals. We're going to use that same strategy from single replacement. And potassium is a metal or a positive ion. So I'm going to box that. The nitrate would be the negative ion, and so would the phosphate. So we're going to circle those. Now, in the end, we need to still end up with a circle with a box. So the silver has to go with the phosphate. And our other product could be potassium nitrate. Now, the trick with these, much like single replacement, is they don't necessarily react just because you put them together. We need to determine, is the reaction going to occur? So the way that we do that is using our solubility chart. This is the same one that was in the instructions, the lecture. And we're going to check what the solubility of the products are. Notice we're doing this for the products after I've already made the switch. So I'm going to find silver on my list, and it's right here. And we're going to look until we see phosphate. So I'm just going to put a little mark here and keep this lined up. So that mark is where we need to look until we see phosphate. Okay, it's pretty far to the end. So here's my phosphate, PO4, and it looks like it's a solid. So since the silver phosphate creates a solid, this reaction will happen. So we would then create our formula equation and balance the equation. Silver would be a +1. So I've got Ag. Nitrate is a -1, so they cancel each other out. We'll just have AgNO3, and it would be aqueous. Plus, potassium is a +1. Phosphate is a -3. So K3PO4, and that is also aqueous. So that's where the AQ is coming from. Now the silver is a +1. Phosphate is a -3. So I would have Ag3PO4. And we said that's the one that makes a solid. And then potassium nitrate, I got a +1 and a -1. So it'd be KNO3. Now, let's confirm, but let's see what state of matter the potassium nitrate would make. So potassium is right above silver. Okay. And we're going to go until we see nitrate, which you'll notice is in this column right here. And that one is aqueous. So we can put an AQ for aqueous after this one. Now, if there's no reaction, in this case there was, all you would simply do would be to cross out the work that you did and put no reaction under it. If there's no reaction, there would be no need to include the formula equation because it doesn't happen. So remember your box and circle strategy. Remember, box equals metal or positive. The circle equals nonmetal or negative. When you finish, you must have a circle and a box together. You can't, like have two circles or two boxes together because that would be incorrectly creating the compounds. And then you check the products for their solubility. Please see me if you have any additional questions.